Good. So my name is Ivo. I'm the chief one to blame for the summer camp, and I will be talking about how Bitcoin works. And few words about me. You probably notice me around, and I'm the guy with the trumpet because I need to, let's say, enforce the program. I'm also co-founder of NetGen, the company that organizes this event. I'm 20-something years in web in many ways, as a developer, as a project manager, as a key account manager, as a tester, architect, speaker. I think I got all the roles. My first web stuff was somewhere in 1999 with Perl. Do anyone remember Perl? CGI scripts, exactly. Yeah, so NetGen, we are a company from Zagreb, 35, maybe 40-ish with some students, and we do web stuff. And 10 years ago, we were kind of, me and my colleague Vjeran, we were thinking about, oh, we should do something else, just for fun. And that was, the Web Summer Camp was born. So one of the reasons why we are here today. We got bored with programming, right? So, okay, so let's go to the topic because we don't have much time. So how it all began with this Bitcoin stuff. First of all, a note. I don't have any cryptocurrencies. I don't care about it. I only care about, I was interested in how it works. So if you think about learning today, should you invest in cryptocurrency or not, you will not get an answer. What I can tell you is the following. If you invest in some cryptocurrency, in 1 year, you could have 5 times. There is a big chance, or a significant chance, that you will get 5 times more value, but there is the same chance that you will get to 0. So just be aware of that. It's a huge, huge risk. Okay, it started with the Bitcoin white paper. Anyone read the Bitcoin white paper? Okay, only Eddie. Okay, good. This was written by someone named Satoshi Nakamoto in 2008. We don't know who this person is. Maybe it's several persons. There are some people think they know, but nobody exactly knows. And it's actually on this URL, and it's not a long thing. It's like 7 pages, and you can read it, and it's very nice written white paper. And it's actually he got lost in 2014. There is no activity on his wallets and anywhere else after 2014. We don't know what happened to him. The white paper describes Bitcoin as a peer-to-peer electronic cash system, and that's the major idea. And now we will see if that actually did it actually happen like this. We are now in 2022, so it's like 14 years later. A bit more history. It actually was implemented in 2009. So the white paper was 2008, and then they started implementing it and running. And the aim was to have a global, fast, cheap, secure, and anonymous payment system. But none of this is exactly true today. And Nakamoto wallets have 1 million Bitcoin, roughly. And today's value, I don't know exactly, but let's say it's $20,000 is 1 Bitcoin, so you can calculate what's the value on Nakamoto's wallet. And the first value of Bitcoin in 2009 was that number, and that was here, or even further here. And the biggest one was around 70,000, I think, maybe a year ago or something. So if you were there close to Nakamoto in 2009, you are probably not here. You are somewhere on some yacht on the Bali or whatever. The interesting thing is that the Bitcoin has a defined amount of Bitcoins that there will be ever, and it's being mined. And I will tell you what is mining, but currently it's around 90% of Bitcoins are mined, and in the next, I think, several decades, the rest will be mined, but then it will stop. There will always be only 25 million Bitcoins. Of course, there are other cryptocurrencies. I'm talking only about Bitcoin now. And yeah, there's a lot of transactions going on, but it's not exactly like a global and cheap system, you will see. And for example, there was in one block, the average transaction fee was $59. That was like also a year ago. So that doesn't sound cheap. Maybe if you are transferring $1 million from Colombia or Venezuela to, I don't know, Netherlands, and then it's cheap. But if you are buying pizza, it's not cheap. Okay, and there's of course after Bitcoin, because it was open source, there was huge amount of these other alternatives. The biggest one is Ethereum, which is more like a platform for building another coins and tokens. And currently there's like 10,000, which is like, it's growing, you know, there is constantly adding more Bitcoins, and then a lot of them failed for various reasons. I would say that half of them are scams, so half, at least. Yeah, so the general conclusion is that it's a wild, wild west. It's a big experiment. This is how I see it. So proceed with extreme caution. You know, don't do anything with money that you need for your retirement or for something like that. If you have some extra money, okay, but if you need that money, don't invest in anything, especially not Bitcoin. Okay, so what we will cover today, this was just a bit of intro. What I want to go through today is some basic concepts that you need to understand before understanding how Bitcoin works. And these are these concepts. And we will start immediately. So we are in a developer track, so all of you are developers. Is anyone here not a developer? Okay. So I suppose that all of others know what a hash function is. You don't, right? You also know. Excellent. So I don't need to waste a lot of time here. So the hash function takes an input string, which could be 1 letter or 1 gigabyte of letters. It doesn't matter. It will produce seem to be a random number. But the point is that if you change 1 byte or 1 bit in the input stream, the hash function will be completely different. And this is a very fast way to validating if the input string was changed. That's basically it. And this is a basis for many other things, not just, of course, Bitcoin. It's an old feature, but it's very, very important for the Bitcoin. The other thing is, hopefully you also understand a bit, there's the symmetric cryptography is when you use the same key to crypt a message. But the problem with symmetric cryptography is that you also then need to transfer the key. With the asymmetric cryptography, you have pair, so you have a public and a private key, and you don't need to transfer the key. So here you have the original text, you encrypt it with, for example, the public key of the person you are sending it, and then you ensure that only he can read it. On the other side, if you encrypt with your private key, everyone else can read it with your public key, but with that you ensure that the reader knows that this is your message. So if you want to send a cryptography or hidden message, what you do is, for example, for the receiver, you take the your private key and his public key, encrypt it, and then he decrypts it with his private key and your public key, and that way only he can read it and he knows that you created the message. So that's basically the asymmetric cryptography. It's important because this is also a baseline for many other things, not just Bitcoin, of course. You know, SSH, HTTPS, all these new things are working like that. But it's important for Bitcoin as well. One of the additional features of asymmetric cryptography is that it's very, it's also used for signing. Signing meaning this is mine, I sign it. So the only one who could create this message is me. It's fast because it doesn't encrypt the whole message. It just encrypts the hash of the message, right? So that's fast, and this is signing, and this is very important for Bitcoin. So the next concept is a wallet. So the wallet is, of course, it has a private and a public key. It also has what it's called a blockchain address. You could imagine it, or you can say it's like an email. It's an address, right? And you also need to remember a couple of things. Again, a warning: if you are using wallets, you need to know what are hot and cold wallets. If you have a wallet somewhere in the cloud, someone else is managing it for you, it's a hot wallet. Basically means that it can be hacked. Someone else can use it. Right? Even software-based. If you have a wallet on your computer or on a mobile phone, your laptop can be hacked, and this is also a hot wallet. A cold wallet is that if you have the wallet on some kind of a stick, which is not connected to anything except when you're signing the wallet. And then you put it in your computer, sign it, and remove it again. That's a cold wallet, and that's what you want if you want to be sure that nobody will take your wallet. If someone takes your wallet, you are done. If you lose your wallet, there is no access to. There is no bank guarantee. There is no state guarantee. There is no way that you can get to your money. If you lose or wallet gets stolen, it's over, game over. So just a precaution. So, and then of course, if you have a harder wallet, the risk is that you will lose it. A lot of people already experience that, or in some way, it's also a risk. So if you have a physical wallet, if you lose it, game over. So those are the concepts, and there's one more concept which is also important. That's a very old one. It's a ledger. Basically, it's kind of a transaction log of economic transactions. In Egypt, they also use it. It's basically a book, right? And saying, I sent you some money, and then you sent him some money. So that's basically a ledger. And we have ledgers today in a bank. So on a bank server, you have a database, a transactional database, and it keeps all the transaction. Of course, it's a great thing, but on the other side, it's centralized. So a lot of people don't like centralized stuff, especially after 2008. That's maybe one of the reasons why Bitcoin happened, right? So then there is another concept. Okay, we want a decentralized system. And one of the answers to that was the peer-to-peer networks. So you have a lot of computers, nodes, usually they're called nodes, and they are linked together in some way, and they have the same permission. There is no central server, nothing. They're all the same, and they can enter the network and go out of the network without any permission, and they do something together. And it's also a new thing. It's not a Bitcoin thing. You know, this was a Napster thing. And I don't know if anyone remembers Napster. That was like, I don't know, 20 years ago maybe. That was the illegal music distributor, which was also basically a peer-to-peer network. And now today we use the, how it's called? not Spotify, but the decentralized system for watching movies, downloading torrents, exactly. So that's another version of PHP network. So the idea, okay, we have a ledger. We want a ledger to be decentralized. So okay, why don't we take the ledger and put it on a peer-to-peer network, and then let's synchronize them as fast as possible. Well, that's not the solution. It doesn't work. Why does it not work? Basically, there are two reasons, or actually two main reasons, and many more small ones. The first one, the big one, is the double spend problem. So I have one node. I run my node, and I say, okay, I have $10. I will send the $10 to Bob, right? And that's okay. But if I'm a crook, I will send the $10 to Charlie and the same $10 to Bob. And the network will then synchronize fast, and it will be false. It will not be correct. So how to prevent this? Another problem is an old problem, which is called like the Byzantine generals problem. So you are a king, and you have your generals, and you want to attack the city. But you need to keep communication with each of the generals to kind of synchronize your attack. So what if some of them are traitors? How do you ensure through messaging that the attack succeeds? And the point here is that if there is enough traitors, the attack will fail. If there is only one, it will probably succeed. So the question is, for a communication system, what's the percentage? Is it 50% or maybe 10%? That's the measurement. So if a system has a 50% Byzantine fault tolerant, that's great. If it has only 10%, that means that 11% of the nodes are enough to break the system. You cannot go over 50, obviously. So that's another problem. So the vague question was how to reach network consensus in the peer-to-peer network, but ensuring there is no fraud. How to prevent people, like, for example, if I'm a crook, I have a node, and I start doing invalid transaction. How the network will just ignore me? That's the biggest question for any kind of decentralized, especially cash system like Bitcoin. So now we are going to the core. So we have a lot of basic stuff. So now we are getting to oh, I have a clicker, sorry. So there's a notion, a concept of chain of blocks. It's also something not new to Bitcoin. The concept is the following. I have a bunch of data. I want to kind of split them in more chunks. But I want to quickly validate if the data is true. So what I do is the following. I have some transaction list, which is a list of sending a list of transaction log of sending the money, and then I create a block, and then I create a header. I hash the data. This is the hash of block of data. I have one more important thing. I will come back to that later. So this is just one number, but it's an important one. I have a timestamp because I want to have it valid in time frames, and I have a hash of the previous block header. And then I have this block header, and I create a hash for the following block. The point here is that it's very fast for a lot of data to see if anything changed. So imagine 10,000 blocks before this one, and you go back and change one bit in the very old block. It's very fast to just check all the hashes of all the block headers and see that it's not good, right? So you could have terabytes of data, chunked into these blocks, but validating that they are not changed is very fast. That's the point of the chain of blocks. Actually, we all call it now blockchain, but in the original white paper it was called chain of blocks, which is basically it. So this was about dividing a lot of data into smaller chunks, which are timed. So they come, like this one goes, in Bitcoin you have a block every 10 minutes. So create the one block is created every 10 minutes. So after 10 minutes you have this one with roughly 1 megabyte of transactional data, and then you have another block, etc. So it just goes, right? So okay, that's a important concept. One more thing, because of this data here, it's not just about validating the headers, it's also validating the data. So it's very easy with the signing is that if in the transaction log I have sorry, just to check. If I'm sending the data, I sign it with my private key, take the hash, sign it with my private key. It's very easy to go through the transaction log and check if the transactions are valid. Valid meaning that if I'm as a user saying I will send you $10, it's signed by my private key, I can easily check it with my public key. It's also very simple to validate that the money is going from the right person, right? So the nodes in the blockchain network, they're actually checking this as well. So it's not about just the whole blocks, it's about every transaction. And then we come to the weirdest thing, the core Bitcoin rule, and it's called the longest chain rule. So what they say in Bitcoin and most of the other cryptocurrencies is the following: the chain of blocks that are valid is the longest one that we know of. So every node has not maybe all data, but at least all the block headers and let's say the metadata, and he knows of all blocks from the 0 block, which was in 2009, if you remember. So all those blocks form a chain, and every node says, or he chooses to use the longest chain. And now I see, well, why is that? How does this help us? And then we get to the very, very non-intuitive answer. And this is why I searched for, I went into researching to Bitcoin to understand how it works. And this is the key thing that you need to understand. To keep this thing, longest chain rule, the blockchain, the whole network, needs to slow down the process of generating new blocks. Not as we had here, saying, let's do it as quickly as possible. No. The Bitcoin says, slow it down. They need to slow it down. Why? Because when you slow it down, it is very hard to create a new block because of time. So because of that, it's very hard to catch up the longest chain. So if you have a longest chain, I have a new node, and I create my false block. I create a block where I spend a gazillion of dollars, and I put it on I send it to the network. I create a block. I send it to the network, but because it's hard to get it, it will be orphaned by other nodes in the network because it's not the longest one. That's the whole idea, is make it very hard in time to create new blocks so that the longest chain rule can be kept, and everyone who wants to create his own chain will not be able to do it because it's very hard to do it. Is that understandable? I mean, is that is it hard to grasp? I know for me it was a bit of, you know, it was a bit tough to grasp this. But that's the whole point of blockchain, the Bitcoin also. So just make it hard to create. Make it hard to create new blocks, so that we can always apply the longest chain rule, so that everyone who wants to falsify the history or add something that the network didn't validate will be orphaned. Okay? Any questions? Yeah? There is always forks. So the thing is with Bitcoin is that they always have, I think, 6 blocks that are kind of 6 blocks that they keep, like, we are not sure yet. And then once the 6th block, which is roughly an hour in Bitcoin, it's set that every block is created every 10 minutes currently. So it needs an hour so for your transaction to be, let's say, approved or baked in, because every node in the system is kind of always waiting. He never knows. He always have this buffer of 6 blocks. Maybe there will be suddenly he will get another fork that he was not aware of, but he will always take the longest one because it was the hardest to create. Yeah? Something like that, yes. Yes. Yeah, yeah. Yeah, I have 6 and then I get a new one, then the first one, I'm pretty sure that it's a correct one. Of course, the network is constantly synchronizing. So usually when a new block is added to the network, it will show up on all nodes relatively quickly, not in a second, but quite quickly. And then every node will decide, is that block valid or not? And basically, if 50% of blocks say it is, it probably is, right? And then, the concept is called proof of work. You probably heard about it, yeah. Yes. No, I will show you. There's one more complex slide. So proof of work, this is a consensus algorithm, is the proof of work. There are other consensus algorithms, but Bitcoin created this one. And this is how it works. So we have a block, and we are trying to create a new block. And we know the previous one. We always know the previous one. We have a hash of the previous one. We take roughly 1 megabyte of transactions that are added to the network, the latest ones, probably the ones that are paying the most, because there is always a fee for every transaction. And then you create a list of the transactions that you want to create the block of. And then what happens is that, remember the not once or nonce number. You start with 0 or whatever number here. And then you create from this, so from all the transaction hashes, this nonce number, you create the hash. And then you check if that hash starts with a defined number of zeros. If it starts with a defined number of zeros, the block is valid. It's okay. Right? So this one here, obviously not. This one not. The other node is also trying to do it with his combinations. Doesn't work, doesn't work. The first one got, in this case, it's defined 4 zeros. We are searching for 4 zeros in the beginning of the hash. And, okay, this one is valid. Great. I created the block. What happens is that I get a reward. Currently, it's a 6 Bitcoin or 6.25 Bitcoins. If I manage to do this, and then I announce it to the network that I have a new valid block. Okay, so this sounds really stupid. Why would we search for beginning of zeros? Well, we want this creating to be hard, really hard. And you create the hard part is you set not 4 in Bitcoin currently. I don't know what's the number of, but it could be 9 or 8 or something like that zeros. So remember that hash is seems like a random number. I mean, it's not a random, but you never know what you will get. If you change even one number, and in this case, you are changing these numbers, you just go 1, not valid, 2, not valid, 3, oh, valid. So the right number here, number 3, was the correct one to get the hash which starts with the number of zeros. And if you put 4 zeros, this will happen in less than a second. If you put 8 or 9 zeros that you need to find the hash with 8 or 9 zeros, it will take roughly 10 minutes. Yes. Because you only need to change one number to completely change the hash. And what's the consequence of this? Of this searching for these zeros? It's wasting a lot of electricity. It's just searching the hash which starts with number of zeros in the beginning. That's completely stupid. But it works. Yes. Actually, in the block, the first transaction is give me 6 Bitcoins. And previously it was smaller. It's mined. It's generated from thin air. But in the protocol it says it should not be more than 21 million Bitcoins. So there are still... There will be no mining, there will be just transaction fees. Because when you sign a block, you get the transaction fees and the block award. But currently, the block award is quite high. So this is 6 times, I don't know, $20,000. So this is $120,000. That's why you have big mining farms that are just searching for fucking zeros. Yeah, well, and currently I think it's around 90% or maybe a bit more, maybe 92. I don't know. And that's the consumption, searching for zeros. That's why we spend crazy amount of electricity. So why is Bitcoin, I think, significant is that it's the first practical decentralized system that solved the double spend problem. So I know it's on one side it's super crazy, it wastes a lot of energy, but on the innovation side, it solved a problem, and it also has a high Byzantine fault tolerance. So if there is no latency in the network, it actually can achieve 50% of Byzantine fault tolerance, which means that you need 50% of the power of the network to actually attack the network and break the network. Means you enforce your version of history. But in practical terms, it's a bit less. So the Bitcoin is 45.5, but the network latency slows down, it goes down as well. Okay, any questions? Or you are still like, I need coffee? No. Yeah. Well, it's not about one node. One node is weak. So in the network, if you have 10,000 nodes, and I don't know how many Bitcoin has nodes, because you can always switch in and switch out. But you have you actually have different kind of nodes. You have a kind of a validation node. You have the mining nodes. There are different kinds of nodes. But if you have 50% of mining nodes, you could attack the Bitcoin. No, but it was never happened so far, because I think there was no data center that at some point achieved that 50%. I will not go into there. There is a very interesting transaction because there's a lot. They call them whales. Whales. When there is a big transaction, like 740, after 9 years, suddenly there is a $24 million moved for one. So there's a lot of these kind of transactions, and it's transparent. You can see all that. All of us can see all the transactions ever been done in Bitcoin, but you don't know exactly who did it. Maybe. One more thing, just to note. So this is a network, and it's also software, etc. So there are forks, like in software, like in Git. You can fork whatever you like. So I can fork Bitcoin. I just go there and fork it and continue by myself. Of course, it doesn't make sense, but because nobody would accept this fork. What happens is there's always some soft forks. Soft fork is exactly what I described. So there are some chains that are longer, and then there is seemingly two valid blocks, but then one is discarded because the other got longer and stuff like that. Then you have the upgrade. So if they want to upgrade the protocol, they need to fork it, and then the network needs to slowly accept it. It could happen that someone makes an upgrade on the Bitcoin network, and then the networks for some reason will not accept it, and then you have the upgrade. And then you have a hard fork. So the hard fork could be planned, but it can also be a spin-off. And this here is a map, a very simplified map of all the Bitcoin forks. And now you have, this is all Bitcoin forks, which happened during the history. And now there is this mind-blowing thing. So when a fork happens, so one side of the network, we want this, and the other network say we want that. They even changed the name, so it's not Bitcoin, but it's Bitcoin Gold or Bitcoin Core or Bitcoin Cash, whatever. Suddenly, all the people that have some amount of value, at first point, they have double because the fork happened. So here, I had Bitcoin, for example, let's say here. So I had Bitcoins, and then suddenly in this point, I have 10 Bitcoins, and then I have 10 Bitcoins and 10 Bitcoin cores. But of course, eventually, the price of each Bitcoin or fork will change. And then this one will go up, this one will drop. But with the fork, actually, you can duplicate the value of whatever people have. It has exactly the same history. Yeah. No, everything works. The question is offer and demand. What is the offer and demand here? And what is the offer and demand here? That's the question. So if, what can happen is that the Bitcoin is, of course, still working, and this one here, someone thinks, it will be worth it. I will fork it. and then nobody thinks if it's worth it. And you can have 10 Bitcoin cores here, or what's called Bitcoin Cash, but nobody will buy it, but because all of people think it's worthless. Right? So it's purely offer and demand. It's mind-blowing. So Bitcoin has a lot of problems. Is it private? Well, you can see all the transaction. If you know a blockchain address belongs to someone, you see his all transactions in history. Is it fast? No. It needs like 10 minutes to get a new block, and then at least an hour to your transaction to be kind of validated or whatever. Is it cheap? No, it's not cheap. You know, if you're buying pizza, it's not cheap. Is it eco-friendly? Of course not. It spends huge amount of energy. All these oral kind of other cryptocurrencies, they try to solve these things. My guess, you know, there's also stability. The price of cryptocurrencies is volatile. I mean, every 10 minutes it goes up 10%, you know, or down 10%. It's like, how do I buy pizza? Is it 1 Bitcoin, 2 Bitcoins, 1.5 Bitcoins? It changes all the time. So there is no stability. I think you cannot solve all that with one cryptocurrency. You cannot make a complete decentralized, completely secure, and completely scalable and fast cash network. It's not possible. Because it's just, if you do this, you will fail at that, etc. You could have specialized coins, but solving all of this is not possible. Currently, we use it for a lot of stuff. I will not go through this. Just, you know, kind of implementations. Because we are on a web summer camp, repercussions on web development in the future. Of course, there are payments, identities. So now you will be probably able to identify with wallet, stuff like that. Storage, I don't know if you heard IPFS, that's like an interplanetary file system, which is a kind of a cryptocurrency based. Some incentive tokens in Reddit, you can get tokens by being agile. Brave browser has attention tokens, so if you watch commercials, you get tokens. There are some open source funding coins, like Git coins. So there's a lot of stuff going on. I will not go there. The most important thing is, in 99% of time, do I need a blockchain to solve my problem? No. Because it's a very special thing to do. This is what the idea is. If you need a system, if you're building something that needs to be decentralized, it needs to be permissionless, meaning anyone can go with a node in and out whenever he wants. If it needs to be trustless, basically no trust, and if it needs to be stateful, because what is a blockchain? It's a big state machine. It keeps track of everything. Then maybe you need it, but otherwise you don't need it in your everyday work.